Okay, Toby claims that for any prime number p, that p squared plus p plus 1 is also prime. Okay, and that's going to be true for any prime number, he says. Says then, show by counter example that Toby is wrong. So this is a proof type question. Okay, and all we need to do is find one example. That's what it means by counter example. Just find one example where Toby's statement actually doesn't work. Okay, because he's saying that he's claiming that it's for any prime number p, p squared plus p plus 1 is also prime. So if we can just find one prime number where it doesn't work, where it isn't prime, then his statement is wrong, isn't it? Because he's claiming for all prime numbers. So we just need one example. So what I'm going to do, okay, I'm going to do like a little table, okay, values, and we're literally going to go through some of the prime numbers, okay, and hopefully we won't have to go through too many to work out to work out one that isn't prime. So we start off with 2, right? So 2 is the first prime number because it's only got 2 factors. Remember, prime number has got to have exactly 2 factors. Okay, 1 and itself. So 1 goes into 2, 2 goes into 2. So if I put it in there, 2 squared plus 2 plus 1. And you know what? I know you could work that in your head, but use your calculator in the exam, right? You know, because you're under pressure. Just take your time, check it on there. Comes out to be 7. Okay, and of course, with 7, 7's a prime number, isn't it? Okay, so I'll put here prime question mark, and actually it is prime, isn't it? Because if you think of 7, it's only got 2 factors, 1 and 7. Okay, 1 in itself, exactly 2 factors, so it's prime. Nothing else goes into it. So he's right there, isn't he? Toby's right. Let's try 3 then. So let's try 3, because 3 is the next prime number, isn't it? It's only got 2 factors, 1 in itself. So 3 squared plus 3 plus 1. So again, work that out on your calculator. It comes out to be 13. Okay, 13 is prime, isn't it? Okay, so he's right again. Okay, so it's looking good so far for him. So we'll do the next prime number. Now, the next number in the list figure is 4. 4 isn't prime because it's got factors of 1, 2, and 4. So that's not good. 5 is prime now. 1 and 5 go into 5. So I put in here then 5 squared plus 5 plus 1. Work that out. Comes to 31. 31 is prime. Okay. 31 is prime. So his statement's looking good. Let's try 7 then. So 7 is the next prime number. 7 squared plus 7 plus 1. So we check that on our calculator. So we get 57. Now you think, oh, 57 sounds good. 57 maybe prime. Actually, it's not prime. Okay, it's not prime because 57 divides by 3, doesn't it? Okay, 3 goes into 57. If you think about it, 3 goes into 60, doesn't it? 3 will go into 57. And if you're not sure, just obviously in the exam you might be thinking it's prime. Just check if it wasn't 57. Obviously, it doesn't divide by 2. Does it divide by 3? Yes, it does. Okay, so that's not prime. So we've found an example here. We could say, look, when p is equal to 7, okay, a prime number, p squared plus p plus 1 is equal to 57, not a prime number. So Toby is incorrect. Okay, so we could say then, look, by counter example, by proof by counter example, we've shown that Toby's statement is incorrect. In other words, he's saying that if p is prime, p squared plus p plus 1 is also prime always. That's just simply not true. We found an example where it doesn't work.